Okay, so now we are in Unit 3, and we're going to talk about why we've been factoring. What's the point of factoring? Let's say I've got some equation like this. X squared minus x equals 12. And we want to solve this out. Well, there's really no way we can solve this with our normal tools of algebra, right? If I added x to both sides, then I just get x squared equals 12 plus x. I mean, I could try to take the square root of both sides, but then I just have x equals the square root of 12 plus x, which is an even bigger mess. And so nothing is really going to work to solve these equations that we've done so far in algebra. So here's where factoring comes in handy. The first step in all these equations is we have to, number one, make the whole equation equal 0. Here it doesn't equal 0. I've got that 12. So I'm going to get rid of the 12. We're just going to take away a 12 from that side. I'm going to take it away from this side. Now, none of these terms can combine together, right? This is an x squared. It's a different type of animal entirely from an x, which is also different from that 12. And on this other side of the equal sign, 12 minus 12, that's the 0. And we wanted the 0. Let me show you why we want the 0. First of all, let's factor this. So x squared minus x minus 12. This minus x is the same thing as minus 1x. So let's factor this. I'm looking for numbers that multiply to be negative 12. Let's make the list. Negative 1 and 12, negative 2 and 6, negative 3 and 4. Flip those signs around, 1, 2, 3, 12, 6, negative 4. And I'm going through the combinations trying to find that negative 1 right there. And I finally stumble upon it there at the very end. Okay, so the first step was to make it equal to 0. The second step that we're doing right now is to factor. And I'm going to show you why factoring is so important. Here that's going to be x plus 3 times x minus 4 equals 0. Now, what good does that do us? Before we finish the solution here, let's take a step back and look at a different question. Almost looks totally separate, but it'll connect here in a second. So if I have a times b equals 0, what do I know about either a or b? So these are two numbers that multiply together and they're 0. Well, maybe one way of doing this is for you to think of two numbers that multiply to be 0. And you might be thinking of 5 times 0 is 0, or 0 times 7 is 0, or even 0 times 0 is 0. Now, can you think of any two numbers that multiply to be 0 where neither of those numbers themselves were 0? Right? It's impossible. One of those, either a or b, has to be 0. Now, this is a and this is b, and they are being multiplied together. So that means either this chunk, x plus 3 is 0, or this other chunk, x minus 4 is 0. Now, that's actually really close to a solution here because it's easy to imagine what value of x I can put in there to make a 0. Let me clean this up again, write it out a bit cleaner. X plus 3, x minus 4 equals 0. In other words, I'm going to erase this letter x, and I want you to think of some number I can write in here that will add to, well, I'm going to add 3 to it, and that'll turn that whole chunk to a 0. So what can I write there in place of that box? And you've probably seen it already. If I was to go in here and I was to write in negative 3, negative 3 plus 3 is 0, and 0 times that 0. So one of my solutions is negative 3. Okay, now let's look at this bit right here. What number could I write in here to make 0? And you've probably guessed it, I can write in a 4, because 4 minus 4 would give me that 0, and 0 times whatever is there is going to be 0. So my solutions are negative 3 and 4. Let's just experiment with one of them and see if it works. Let's plug that 4 back into the original equation and just see if it satisfies it. So we're going to do 4 squared minus 4. That should equal 12. 4 squared is 16. 16 minus 4 equals 12. So yeah, that does work. So 4 is a solution. Negative 3 would also work in that as well. Okay, let's do another one of these here. Let's say we've got x squared plus 7x plus 12 equals 0. Go ahead and solve this one out. All right, it's already equal to 0. Remember, our first step is make equals 0 if it doesn't already. Step number 2 is factor. How do we factor? Factoring, we circle that number, 12. We make our table, 1, 12, 2, 6, 3, 4. And 3, 4 is going to be my winner. X plus 3, x plus 4 equals 0. And the solutions are -3 and -4. Why -3? Because here, if I put in a -3, that's going to turn that bit into a 0. And if I come in here and I replace that with -4, that's going to turn that bit into a 0. And so the game here is really to make zeros. And you want to make a 0 on that side. You want to make a combination, some value of x that'll make that into a 0. So the goal here is all about the zeros. Okay, let's do another one for you to solve. Let's do this. Let's do x squared minus 7x plus 10 equals 0. Okay, it's already set to 0. We're going to factor this, x minus 5, x minus 2 equals 0. Why -5 and -2? Let's just do that factoring so you can see what I'm doing here. 1 times 10, 2 times 5, -1 times -10, and negative times a negative is a positive 10, and a -2 and a -5 again will give me a positive 10. This is the combo I want because that's a negative sign. All right, so -5, -2, give me a -7. -5 times -2, give me that 10. And so now my solutions are 5 and 2. Why 5? Because if I replace that letter x with the number 5, 5 minus 5 is 0, 2 minus 2 is 0, and so those are the numbers that make zeros there. Okay, let's do one more with a little bit of extra work here. Let's say we've got x squared plus, let me think of a good one here, 10x equals -16. Okay, so first step, number 1, you have to make it equal 0. It's not equal to 0, it's equal to -16. So to make it equal 0, I want a 0 on this side. We're going to add 16. And that's going to make a 0 because 16 minus 16, that's 0. So now I've got x squared plus 10x plus 16 equals 0. Now you're going to factor that. 16 is what? 1 and 16, 2 and 8. Aha! There's my combo. Not too hard. X plus 2, x plus 8 equals 0. X equals -2, -8. And you're done.